Welcome back to Chem 330, Week 2 discussion. And today the concept we're going to discuss is alkenes. And apologize if I sound a little bit rugged. I do have a bit of cold. So the topic we're going to discuss are alkenes. And if you remember that when I first started discussing organic compounds or carbon containing compounds, I mentioned there are three kinds: alkanes, alkenes, and alkynes. Okay, we've already finished our discussion on alkanes, moving on to alkenes. Okay, similar to how alkanes had a general formulae of CN H2N plus 2, alkenes have a general formulae of CnH2n. Okay, and N, as always, refers to the number of carbon atoms. Okay, so with that said, let's say if we have 5 carbons in our compound and we know it's an alkene. Okay, now after we finish this first set and learn how to name it, given a formulae, how do we know if that compound has a single or double bond? Okay, so if I have 5 carbons, that means going by this formula right here, I should have 10 hydrogens, right? Now, alkanes are characterized by all single bonds. Every bond is single bond. Okay, alkenes are characterized by a unique double bond. Okay, and then you obviously will have single bonds also in the rest of the compound, but you must have at least a double bond set. Okay, now in the double bond, the bottom, it typically corresponds to sigma. Okay, and the other bond corresponds to a pi bond. Okay, that means when you say a double bond, that means there's a single bond and there's an extra bond. Okay, and that's what we refer to as a pi bond. Okay, so every compound will have a single bond. If a compound contains a double bond, one of the bonds have to be added, and that'll be the pi bond. Okay, with that said, let's go ahead, and since I've told you this is an alkene, okay, so it will have a double bond, but later I'm going to give you some workout problems where I will not tell you whether it's an alkene or alkane. Okay, so let's write our straight chain isomer. So we got 5 carbons, right? And as I said, since this is an alkene, there will be a double bond. Okay, so I'm going to go get my blue, and so I can have my double bond here. The good thing with alkenes is you got to anchor the double bond and work your isomer around that double bond. You will have multiple isomers. Okay, so if I have it here, and then I can also have 1, 2, 3, 4, 5, and then I can have it here. Okay, guess what? If I put it further to the left, okay, if I put it further to the left, that means I will end up with one of these, right? So that means this is where we end with our straight chain possibilities. Okay, now let's go get our black color again. Now this time around, instead of 5, let's start with 4. Okay, 1, 2, 3, 4, and the same rules apply. Okay, just because we go to a different compound doesn't mean the rules change. Okay, they don't change much at all, to be honest. So we cannot put that extra carbon on the terminal carbon atoms, right? But the double bond can go anywhere as it wishes. All right, so I'm going to put my double bond, say, over here. Okay, and then I can now put my carbon here, right? I can put my carbon here, right? That carbon still has 4 bonds. Keep in mind, just don't fill up isomers and completely lose track of how many bonds there is to the carbon. Some people do that because they get carried away in the process, right? Now, this is slightly different, right? I can now move, right, I can still retain my double bond here, okay, right, and move it to this carbon, right? That is different. That's not the same as the one above, right? Because I still can't put them here. That's it. I can't go anymore. This will be my third and fourth, right? Let's go see if we can create more with just the 4 itself, okay? We can have, as I said, first you keep the bond fixed, look for isomers, okay? Now let's say we put our double bond for the same 4 carbon in the middle, okay? And now we can't put them in the end, the extra carbon, so it has to go here or here. It doesn't matter where you put it. You can only have one of the two, okay? So I'm just going to put it here, right? This is not same as this is not same as that, okay? It's a completely unique one on its own, so that'll be the 5th one, right? Right, that's the 5th one. So let's go get, that's it, you're done. If you move it to the end, it will be one of 3 and 4. So let's go get 3 now, okay? And we know we can't put it, let's get our red. We know we can't put it over here, right? Which means the double bond must only go here or here. Let's start with this, okay? What is the problem here? Okay, it's not the double bond that's causing us the problem, it's the remaining 2 carbons. We got 2 more, and even if you put it here, this carbon now has 5 bonds, and that's not acceptable, right? So this is it, folks. This is your TSA checkpoint, okay? What that means is a carbon with 5, for this particular alkene, this is all the possible isomers. Now let's go fill it with hydrogen. So CH3, CH2, CH2, CH, CH2. Okay? Same over here. CH3, CH2, CH, CH, CH3, CH3, CH. This already has 4 bonds, so it doesn't have any. We'll just give 3 hydrogens here, and this will be 3 hydrogens, 2. This already has 4 bonds, so we'll just move on here. Okay, if you notice, I did it systematically, and none of the isomers I already have coexist with some other isomers. They're all unique in their own way. So these are the 5 possible combinations possible, right? Now let's go try to name these, okay? So let's go get our black and rewrite the compound. So it'll be C5H10, I believe. That's what I had, right? So this was one of the isomers we wrote, CH3, CH2. Let's start with the straight chain because it's the first on the list. So CH double bond CH2. Now keep in mind, this compound has a double bond, right? So 5 carbon, okay, is pentane. If it is an alkane, okay, if it's an alkene, we just replace the A and E with E and E, okay? So what does that translate then? 5-pentene, right? Right. Oh, sorry, it's not 5-pentene, it's just pentene, right? 5 is just the number of carbons, right? Right, it's pentene now, right? This is 5 carbons, right, folks? This is 5 carbons, right? So we said that's pentane, but since it contains a double bond, it becomes pentene now, right? Now, it's important to know where you start your numbering, okay? So let's go get our blue, okay? Whenever you have a double bond, even if the molecule is crowded on one side, but the double bond is on the opposite side, you start numbering from the side with the double bond. So I can only start from here. Now, which number do I give? It's between 1 and 2. It's always the least of the 2. So it'll be 1, hyphen, just write the name, pentene. Okay, let's do a couple examples because this is the first time most of you probably have seen it. So let's go ahead and draw one of the 4 bond isomers that we did. And we did do, I believe, this is one of them. This was one of them. Okay. Right? So we've now, again, you've got to not just forget what you learned earlier. Again, you've got to find the longest chain, and the longest chain, here is the most important thing. Okay, let me draw 2 different colors. There are 2 possible long chains, right? If you go down, this becomes your derivative, right? Let me draw this. Okay, and now I'm going to rewrite this whole thing one more time. Okay, just one more thing, because you will definitely have that confusion. How do I know which chain to choose? They both have 4 carbons. Well, in the alkanes, it does not matter which of the 4 carbon chain you chose, but in the alkene, it does matter. Okay, so I'm going to go get my red. Okay, if I choose this, I still have 4 carbons, right? So let me get my blue over here. This is 4 carbons as well. Okay, now let me get my red. This, on the other hand, if I go straight, I end up with the same 4 carbons. Okay, you should always choose the chain that contains the double bond. Okay, so this chain is not possible, which means this is hanging from the chain, right? So similarly to how we named earlier, 4 carbon means butane, right? And we replace the A and E with an E and E if it contains a double bond, right? So it's E and E, right? So it's butene, right? And as I said, it doesn't matter it's crowded or not, you start numbering from the side that contains a double bond. So it's 1, 2, 3, 4, right? So there's 2 numbers that's important here. The double bond itself is between 1 and 2, so we give it 1 butene. But we're not done yet. This is the last name of the compound. We still have to go get the first name. And this is a methyl group which is hanging off the 2nd carbon, so it's 2-methyl 1-butene. Does that make sense? That's how you name alkene compounds. All right? So let me leave you all with a question that is probably persisting in your mind. So keep in mind, because we're hankering, when we write isomers, hankering the double bond, move other carbon around, and then within that same, say 4 carbon chain, you can move the double bond and then again start moving carbon. So we're going to have a lot more isomers. So when we tackle this type of problems, we would try not to, I would not have you write 60 isomers, okay, just have you write 3 or 4. So here's what I want you to do. For this following compounds, okay, draw at least 4 isomers. Okay, doesn't matter which ones you draw, you just have to have 4, and name all 4 isomers. All right, go ahead and pause the video. I'll post the solution to this problem as a separate video, and we're moving on to a different concept in the next video.